Welcome back. Today we're going to discuss, in this lecture, the stack. So a stack, as we've discussed when we were discussing queues in the previous lecture, is a data processing container. It's a last in, first out structure. So data processing containers have to do with the order that you process the data that comes in. You can't deal with all the data at once, say, and you're going to order it in a certain way. A stack orders the data in reverse. It handles the data in reverse order that it arrives. It's last in, first out. So it's like a stack of plates in a restaurant. So you stacking plates in a restaurant, put 10 plates down, 10 plates down, 10 plates down. The last plate in that stack is the first one that's drawn out. So typical operations, push operations. You add the element to a top of the stack. Pop operation, you remove and return an element of the top of the stack. So push, push, push down, and then pop off the first element, next element, and so forth. The peek is like the pop operation, but it returning the element to the top of the stack, but it doesn't remove the element from the stack. So push, pop, and peek are the major elements for the stack. So let's get to our stack challenge. I want you to write a class called myStackInt and implement the push operation, again, adding the element to the top of the stack. Pop operation, remove and return the element at the top of the stack. A peek operation, which returns the element at the top of the stack but doesn't remove it. So implement these with a stack, myStackInt, and the elements in this case will be integers. So here's a hint. You can use either an array list or a linked list for the internal implementation of this. That's the private data member. Remember, you cannot declare an array list of int. You cannot declare an array list in Java of primitive types. Instead, you have to use the wrapper class array list of integer. And all the action for a stack is at the front. Push to the front, pop to the front. So that's a big hint. So pause the video at this point, and I'll return with my solution. So here's my implementation of myStackInt. So I have public class myStackInt, the pop operation. We remove. So let's take a look here at this private data member. I have a private data member, an array list of integer called stack. We allocate it right in the same line. And then the pop removes from the front of the list. The push also adds to the front of the list. Remember the hint. All the action is at the front. Push, push, push. Always going into you can imagine elements going into the front of this list. Then pop, they remove the elements from the list. And then peek, of course, gets the first element in the list, but does not remove it. Let's take a look at the test driver here. So now we have the test driver. So the test driver here, I have main, which calls test stack. Test stack instantiates myStackInt, the class I just created. We push 323, 10, 55, and then we pop 4 pops in a row. So we push 4 elements and then we pop 4 elements. Let's take a look at this running. And we can see that we've successfully reversed the order of input. So last in, first out, 55, 10, 323, and 3. So whenever you need to do a process of data in reverse, the stack is the structure you need to choose. We'll set a breakpoint here, run the program in the debugger. Trace into, add to the front of the list, push again, adding to the front of the list, adding to the front of the list. Let's trace into one of the pop operations. We remove from the front of the list and print it out, and there we go. We've successfully implemented a stack. Now here's something to consider. Here I have myStackInt, which works fine for integers, but suppose I want a myStack of doubles, or of student, or of employee, or of any other class that I need to deal with. One approach to solving that problem would be to copy this code. It's logically pretty simple, and then let's say I changed it to a student, myStackStudent. everywhere that the integer appears, then I would replace that with a student declaration. And I would have then a stack that behaved as a stack of student type. If I wanted a double, I'd do the same thing. Again, copy this code, manually copy the code, and replace the data type that pop returns, push takes as a parameter, peek returns, and the type of data structure down here, we manually copy the code and rewrite it. But there's an easier way, and that easier way is right in front of us. Right? What the compiler does, this is called the array list is called a generic class. And what it takes in the angle brackets is the data type for that particular instance of the array list. So when the programmer that creates the generic array list specifies this, the compiler then sees that specification. It generates no code at that time. When does the compiler generate code? When it actually sees this declaration. And it takes the logic for the array list and then fills in this data type, this generic data type, everywhere where it needs to. And we'll see how to do that in the next section of slides. Okay, so we get to challenge 2, creating a generic stack class. So we're going to change, what you do is change myStackInt and declare it this way, myStackT. Very similar to the syntax for when you use the array list, for example. You're using a generic. When you declare the generic, you use the same angle brackets and you put a T here. That T is a stand-in for a type. It's commonly used as a T. You'll see this when you look up online for online tutorials of how to write generics. You'll see the T being used there. But it's commonly used, but it's not a requirement. It's an identifier like any other identifier. You can call it what you want. So it's a stand-in. It's also called a dummy type. So what happens is then you take your myStackInt, and everywhere we return an int, you instead specify T. And so when it sees myStackInt, it does that replacement work for you. It replaces the dummy T with int. In this case, it would replace the dummy T with double, and it would replace that T with student if you declared it this way. So then you could easily say my stack is this type of stack, this type of stack, this type of stack. Therefore, the compiler automatically duplicates a code and replaces the dummy type with the actual type. So try this challenge, and I'll return with my solution right after this. So let's take a look at my implementation of the generic. So remember the myStackInt, and here's the file called myStack here. So replace the myStack with this here. So the compiler sees this, and it knows we're writing a generic. Then I replace, look, back to here, replaced angle bracket T, and then every place the integer appears, I put that T in there. Again, this is a stand-in or a dummy type, right? So that T, here, 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 and here, when the compiler sees the actual instance of it, it will create this code and fill in the proper data type of the data we're using. So this should be very familiar syntax from the array list. myStack, the data structure we're using, the data type going inside the angle brackets here, and the compiler will generate that myInteger stack for us. Run this, and we see that it works the same way. 55 comes out first. It's the last in, first out. 55, 10, 323, and 3. The cool thing about this is we also have a stack of string here. So this will be a stack of string. I didn't have to write any code. The compiler does the work for me, replacing this T with string everywhere when it sees this actual instance of it. So creates code for us, given the pattern that we've laid out here. So here we're going to push roses are red mostly, and then we pop off those off the stack. Let's change this myStack call to myStack2, and we'll test this version. Mostly red are roses. So the stack, first in, first out changes the order of processing. So that concludes our lecture of generics, and you'll get an assignment with dealing with generics to follow up on this. Thank you.